So good morning, everyone. I'm Brian Matthews. I am the project lead within the Scientific and Computing Department at the Science and Technology Facilities Council. A bit of a mouthful. I'll kind of explain who we are a little bit later. And what I'm going to do is give a brief overview to DAFNI, just to sort of introduce the context which the demonstrations and talks later on are going to go into. So let's move on without any further ado. So firstly, why DAFNI? Why are we doing this? Well, we're kind of, what we're trying to do is support modelling for built environment, and this is a sort of slide which I've shamelessly stole from the Centre for Digital Built Britain, which kind of explains what we're trying to do. We're trying to do models of the built environment as a whole, and that has various components in it. It has economic infrastructures, so transport, energy, water, waste, the sort of systems in the built environment. Then there's social infrastructure, things like where people live, where people work, how people move around, how they access healthcare and other services. And then the natural environment, so where the green spaces are, what the weather's like, where the water comes from, and all those sorts and goes to, and all those sorts of factors. So combining all these things together into a built environment using individual models of it, so we can then do this cycle, which is on this thing, which is sort of build, design, commission, and plan efficient infrastructures, and then while they're in use, operate and maintain them, and ultimately decommission them. So go through all stages of the life cycle of those components in the built environment. So this is an active area of research, obviously. I'm sure many of you are involved in this, and this is getting an increasingly large number of technical challenges. As it gets more and more compute intensive and more data intensive. So we're getting more and more data, we want more and more resolution, our algorithms get more and more complex, we need more and more computing resources. You just want to be able to scale up those models. And then when you got these kind of these complicated integrated models for the sort of whole picture of the built environment we had on the previous slide, you need to be able to do a lot more integration between models. So you want to be able to integrate across different sectors, between water, energy, land use, digital transport models, digital infrastructure, and transport models, integrate them together and integrated with those environmental and economic and social environments, sorry, those natural and economic and social environments, and also integrate between scales. You may want to look at an individual item of equipment or an individual vehicle, up through sites, organizations, regions, cities. So we're going to integrate all those different scales, both temporally and spatially. And that's sort of a very complicated picture doing integration, and a very complicated data integration problem from different sectors. So you need common standards for interchange and interoperation, common standards. And if you're kind of adding extra capability on this, like digital twins, not only need all this integrated data infrastructure, you need also sort of real-time links to this cloud of real-time sensors, and being able to respond rapidly to give appropriate decision making back into the physical twin. So a very complex, a much more challenging computing environment than perhaps we've seen before. So what are the kind of things that we need? Well, we needed a community hub, a place where we can share and combine data and models together. So do that integration task, support those collaborations from all those different sectors together. And also, this takes a long time, the long-term thing. We want to be able to build on previous experience. So a place where we can provide a legacy, a place where things can survive longer than just one project. So this is what we're trying to do in DAFNI. Provide this sort of hub to the infrastructure research community. We have a hybrid high-performance computing platform. I won't talk much about that, but some some computing power behind us so that we can scale up both in data and in compute. We provide some, and on top of that, we're building a software stack which gives us a secure repository for that data and models for the infrastructure. From all kinds of different places, very heterogeneous, but all brought together in one repository. And then on top, using that repository, a collaborative platform to research and develop multi-system models of our assets and systems and how they interact with the natural and social environments, and a place which we can keep those things for the long term, so we can provide that curation for long-term accessibility. So that's what we're trying to do. How are we doing it? What can we actually offer? Well, DAFNI, which stands for the Data Analytics Facility for National Infrastructure, is a 4-year project. It's just been extended, so it's actually a 4.5-year project under the UK Collaboratorium for Research in Infrastructure and Cities programme, which has been going on for the last 3.5-4 years. Formed by 12 partner universities, led by the University of Oxford, and also including Southampton, where Adrian comes from, and others, and Sheffield, and UCL, where other speakers are coming from today, and ourselves, STFC. So we're a research laboratory based near Oxford, between Oxford and Reading, Oxford and Newbury, and our job is to provide large-scale infrastructure, including computing infrastructure, for the research sector. So we are a development and hosting partner for the platform, and then hopefully we can build this to build partnerships across academia and with government and industry. So what do we have? Well, the functionality. Well, so this is some screenshots from our platform. We have login. Well, a login's, well, you expect that kind of is a proxy that we have a sort of security architecture. So we have sort of strong access control on different components. There's quite a fine model to deciding who can access what, fine-grained model to access what. We have then ways of uploading and displaying and accessing data with metadata of that data, a data catalog which kind of organizes and allows search over those different data resources, and then similarly for models, we can allow people to upload models and execute models of their choice, and I'll explain a little bit that later. And we can then allow people to build those complex systems of systems workflows by joining them together using a sort of graphical, semi-graphical user interface, and then visualization tools which we can use built on top of those to run visualizations. The visualization tools are some of them are still under development. Some of them are integrated in, some are still in development. We have them, but they're not fully integrated into the platform yet. So that's a coming soon. So just to talk a little bit more about a couple of those things. The information infrastructure, we definitely provide an information infrastructure through our data hub with what we call the NID, the National Infrastructure Database, providing a trusted secure space to hold and access data, where we can import data from different sources and link it together. Link from other sources, and it's based on a common metadata standard called DCAT to give common search and access. So this gives us a platform for integrating and combining data. We'll have a demonstration of this a little bit later on. And we can take data from more or less any source. And one thing we're looking at and we want to work on over the next year or couple of years is enriching the data framework around that using an ontological framework. We've done some preliminary work with some other champions. Adrian mentioned the champions program. We have some other champions looking at ontological frameworks, and we hope to bring some of that onto the platform over the next year or so. And the second sort of major component is the NIMS, National Infrastructure Modeling Service. This is where we support user models. We can upload models from more or less anywhere into our model repository. we use a system called Docker, which supports containerization. This sort of packages up the model, so it gives us a lot of independence from the underlying code base and operating system, so they can run on our platform, they can combine with the data on our platform without a lot of modification of the code by the user. You have to use Docker, but you don't need to change your code to adapt to our system in quite the same way. And this allows you to share models, and it's all built within the same security framework. They can run on our HPC cluster. We use Kubernetes to orchestrate these containers and do the management of their scheduling and running. And so we can scale up models to give them more compute, access data in our things, and then run visualizations all within the same security framework, and then combine them together into workflows, chain them together, a couple models together, give these more complex systems of system models, and then those workflows. Allows us to couple across sectors and at different scales. So that's a kind of a very brief picture of what it. So sorry, there'll be a demonstration of this later as well. How is DAFNI being used? Well, I won't go through most of these examples because we have more detailed talks about them later, but I just to quickly mention. So we've done some work with the University of Southampton on station demand, looking at where new railway stations can be built on a railway and at where the catchment comes from. This is another thing which is slightly different, which is looking at economic development in the Oxford-Cambridge arc using a model from University of Leeds called CIMIM. We've been working with the ITRC consortium on the NISMAD system, and I think Adrian himself is going to speak about this a bit later, which includes a number of different systems, including energy, supply and demand, and water and transport. So we've been bringing that. That's been a major pilot on our platform. Has been bringing that onto the platform. And Christian's going to talk about this later, which is digital, a move towards a digital twin model where we're doing a traffic digital twin in Sheffield. And so I don't want to talk about that anymore because Christian will be talking about that later. I don't have a slide for Just, but Just has also got another example which he's talking about later. So all three of those will be described in more detail later. So just to summarize where we are, well, DAFNI's open for business. It's been a 4-year development program, extended by a few months this summer. So we are nearly finished on that phase, on our development phase. There's a long time spent developments, gathering requirements, doing design, doing implementation, doing lots of pilots. We've done a very intense development over the last year and a half to get the platform into the state where it is now. And we've been getting a lot of pilots on the platform directly through pilots. Some of those examples have been from pilots. Others have been through Champions program, as Adrian's mentioned. We've done a lot of webinars like this and hackathons. We've done a lot of outreach, and we're planning a final event now going to be at the beginning of July this year. So if you are interested in it, please come and talk to us. We're now kind of going into phase 2, which is our long-term sustainability beyond September. And we're going to looking at a hybrid platform model with some platform support and participation in projects. And we're kind of moving that towards that production environment now. But there's still still a lot of development, still a lot of things we want to do, a lot of things we want to add. For example, I've already mentioned some of these, more richer support for digital twins, richer support for machine learning, a richer data information infrastructure with the ontological work I mentioned, and enriching the framework and getting more powerful the way we integrate models together. So still a lot of development things we want to add. So that's kind of, we want to talk to users about those requirements. So just to summarize where we are, final slide, DAFNI is an environment for research collaboration in modeling, exploring new ideas, with a HTC platform, allows data sharing across a common information repository. We can scale and couple models together with a long-term legacy for keeping those models accessible. There's a lot of work to be done, particularly in these areas, but we believe we have a platform now which allows to support research in the sustainable development of infrastructures for all kinds of different scales. So I think I'll finish there. Thank you very much. If you are interested in further details or log in, we can please contact us on either directly addresses like this or on the info at DAFNI email address I had on the previous slide. Thanks very much.